Imagine a grandchild who is startled at noises, even though she's never lived through her grandmother's trauma. Could fear, something so deeply emotional, be inherited? Hi, my name is Mia Boykin, and today I'm exploring the question, can trauma be inherited? And how these experiences might leave epigenetic marks on our DNA that shape how we respond to stress. Why does this question matter? Well, we already know that trauma changes the mind, but what if it changes biology too? Psychology explains how trauma reshapes memory and emotion, but genetics shows that extreme stress can alter the expression of certain genes involved in the body's stress response. That is why this question matters. It connects with what we feel with what our cells remember. Here's how that system works. It is the stress pathway, and it starts at the HPA axis, which acts like the body's thermostat for stress. When we face danger, the brain releases CRH. The pituitary sends the ACTH, and the adrenal glands release cortisol. Normally, cortisol levels fall once the threat passes, but chronic trauma can keep this system switched on. In people with PTSD, genes like FKBP5 and NR3C1, which regulate cortisol, often show altered methylation. The DNA sequence stays the same, but the body reads it differently. One of the most striking discoveries came from a study by Diaz and Ressler in 2014. They trained mice to fear the smell of cherry blossoms through shock therapy. Amazingly, their pups, who never encountered that scent, also reacted with fear. Researchers found that methylation changes in an odor receptor gene, the OLFR151, in both generations. It is as if memory of fear was passed down biologically. Humans show a similar pattern. In 2016, by a study by Yehuda, researchers studied Holocaust survivors and their adult children. Both groups had altered methylation on the FKBP5 gene, which helps regulate stress hormones. The trauma experienced by the parents left a measurable chemical mark that their children inherited even decades later. And this research continues to evolve. In a 2024 study by Bozak, he examined epigenetic biomarkers of trauma across multiple generations. They found that individuals exposed to severe stress showed methylation changes in stress related genes like FKBP5 and NR3C1. And their children displayed similar patterns even without direct exposure to trauma. These findings show that trauma can leave molecular echoes that extend beyond just one generation. Why does this matter beyond the lab? Well, if biology remembers trauma, the implications reach far beyond the lab. Chronic stress from war, poverty, or discrimination does not just shape opportunity, it might shape gene expression across generations. But there is hope. These epigenetic marks are reversible. Supportive environments and therapy can gradually erase or soften them. Our biology listens to experience. It can record pain, but it can also record recovery. Our DNA carries memory, but it can also carry healing. We cannot change the past, but we can shape what biology remembers. Every act of care, every generation that breaks a cycle of trauma adds new notes to that story. That's the lesson of epigenetics. We aren't trapped by our biology, but we are in a conversation with it. These are my citations, and thank you so much. I hope you guys enjoyed.